Hey, chemistry. Today I want to talk to you a little bit about something called limiting reactants and percent yield. I am partially down into the slideshow. Looks like slide number 16. Here's where I'm starting off here. That's on Google Classroom. If you're watching this on YouTube, go ahead. You can pull up your slideshow and look at this anytime you want to. Now, we've been learning about stoichiometry. Stoichiometry is being able to figure out how many moles product you would get if based upon how many moles of reactant you have. And so you can kind of figure out if you have, let's say, so many moles of reactant, how many moles of product you're going to get in your reaction. Now, this is really useful because you can basically use this to figure out how much you're going to get of a product if you have a chemical reaction, which is kind of the purpose of chemistry. There's two ways we can kind of measure that, and some ways we can look at that, and that's limiting reactants and percent yield. So I wanted to talk about it really quickly here. It's going to be short and sweet, but I just want to talk about it. Limiting reactants are basically what is stopping a chemical reaction. A chemical reaction is just going to keep going until it's used up. So it's kind of like once it gets started, it's going to keep going, and it's going to keep going until one of the reactants is used up. And whatever reactant is used up first is the limiting reactant. So sometimes it's interesting to figure that out because if we do a reaction, we want to know how much product we're going to get. And the limiting reactant is going to tell us how much product we're going to get, because after the limiting reactant is gone, it's going to stop. And then if there's any other leftover reactants, like stuff that doesn't react, we call those excess reactants. So we want to know how much is left over sometimes, because we want to know, okay, well, if there's this much left over, then how much more of the reactant do I need to add in? Okay, so here we go. Let's take a look at a problem here. You can determine the limiting reactant in a reaction when given the mass of the reactants. Okay, so you can use mass. So for example here, we've got, let's see if I can move this for a second here. There we go. Fair enough. 40 grams of sodium hydroxide, that's NaOH, that's down here at the bottom, reacts with 60 grams of sulfuric acid, that's HSO4, okay, right there at the bottom as well, okay, and it makes stuff like that, okay? So let's move on. It looks like that for every 2 moles of sodium hydroxide, okay, you need to react 1 mole of sulfuric acid. Let's take that information and see which one is the limiting reactant based upon those masses. That's important. Okay, we're looking at seeing which one is going to be the limiting reactant based upon these 2 masses here. Well, let's convert them to moles, because moles are always going to be an easier way of comparing 2 things. This is what we've been talking about for a while. You want to be converting everything to moles to compare them, and that's what we do in stoichiometry. We're turning them into moles so we can use our mole ratio. Remember, we have our mole ratios. That's what we're going to do next. Okay, so here we have 40 grams of NaOH, and 40 grams of NaOH make 1 mole. Okay, so that makes 1 mole. That's convenient. Okay. That's because NaOH, 40 grams, is the molar mass of NaOH. Now, for our sulfuric acid, it's a little different. Here we have 60 grams. That's a lot less than our molar mass of 98.09. So it ends up getting 0.612 moles of H2SO4. Okay, let's see what that means. So we have to compare them. Okay. Well, the actual mole ratio from our actual numbers of 40 grams, 60 grams is 1 mole and 0.612 moles. That's from back here, from our math here. And our mole ratio from our equation is 2 moles to 1 mole. That's from our equation over here. You can't really see. There it is right there, the equation on the bottom. Okay. So we want to figure out how close is this? Well, it's actually really close. If we divide it by 2, we get 1 mole to 0.5 moles is our mole ratio from the equation, which is really close to our actual number here, okay? But what does that mean? What is this all telling us? Well, all of the 1 mole of NaOH is going to be used up. There's still going to be some of our sulfuric acid left over, if you can see that. Look, if we have 1 mole of NaOH, okay, it's going to react with 0.5 moles of H2SO4. We have 0.6, which means we have 0.112 moles left over, which means that sodium hydroxide, NaOH, is the limiting reactant. Okay, once we react, there's going to be leftover H2SO4, and that is the excess reactant. Okay. I don't want to do mass here. So this is how we can kind of calculate the mass here. So if we want to calculate the mass of that limiting product, we says here we have 1.112 moles left over. Well, how do we figure that out? Well, here's the way. We have our original mole, our limiting reactant. This is how much we have of it. Then we want to transfer that into moles of sodium sulfate. This is kind of one of our products. Okay, we want to figure out how much product we're actually going to get. Okay, this is our mole ratio from our equation earlier on. Okay, right here. So it says here in our molar, if I get this thing to fall off here, we have for every 2 moles of sodium hydroxide, we're going to get 1 mole of sodium sulfate. Okay, so there's our ratio there. And then for every sodium sulfate mole, we're going to have 142.04 grams of it. So we multiply across, divide across, and that is our massive product, okay, that we're going to get with our limiting reactant. Okay, because remember, our limiting reactant goes here, and we just do stoichiometry. All we need to do is basically do the stoichiometry part with our limiting reactant to figure out how much product's going to be. If we did the stoichiometry with our excess product, then we wouldn't get the proper number because remember, there's excess reactant left over for that section. So we always use our limiting reactant in a stoichiometric problem to figure out how much product's going to be there. And that's the whole purpose of it. Okay. We're going to skip this calculating percent yield for right now. We'll talk more about that later if we have time, but I want you to practice today by doing the Edpuzzle and practice a little bit of calculating limiting reactants. All right. Hopefully that was helpful. Have a great rest of your day. Thanks for listening.